off your satellite, right? If you don't have satellite, then I can't really help you. But for this purpose, we have a satellite outside in our sat farm. That's bringing down our Eagle feeds, pretty much every AFN feed, right? And here we're taking the radio feeds off that satellite. Right there, we're taking all the other channels, right? So just ignore all the other stuff. Just focus on this part. So we take Eagle in off our satellite. It comes off the splitter, right? Off the splitter, they go into these decoders. The decoders is able to tune in to the AFN programming, right? So on the output of these decoders, you have something called SPDIF. It stands for Sony Philips Digital Interface. That's what it stands for. So it's pretty much a commercial grade of digital audio. It's commercial. It's not professional yet, right? So after the Cisco's out SPDIF, we go into these Henry boxes. The Henry boxes is going to convert your SPDIF into AES, which is a more professional grade type audio. I don't know what it stands for. I have no idea. Does anybody know what it stands for?
AES on the fly. What is it?
I don't know. All I know is it's a more, just think of it as a more professional grade audio. It's not the same thing as SPDIF, so that's why we have to convert it. We have to convert it because our Axia devices, our nodes in particular, understands AES, not SPDIF.
Where are the
so
boxes?
they are in the back of the rack.
You're gonna see that.
Yeah, you're gonna see it. You're gonna see it.
I'm sorry.
No, you good. You good. Any questions, welcome. There ain't no such thing as a stupid question.
Yeah.
You know, but I'm gonna answer it as truthfully as I can. All right. But keep in mind that that your Henry boxes is going to do your conversion for you, so that your Axia devices can understand the audio. You know, all that stuff is going. You know what I'm saying? So you gotta have these boxes in between. Now, out of the Henry boxes, you got all right. So one in SPDIF, 2 outs. You have 2 outputs coming out of these Henry boxes. One output goes to one set of the nodes, which is your left side, Studio A. Studio B, there you go. Fan of white right here. Is your Studio B is your right side. So that's your B side of your studio. So that's why we have our 2 outputs coming out of the Henry boxes. Now before it hits these X nodes, they have to go into a patch panel, right? So does anybody know why it has to go to a patch panel?
You got isolated.
Yeah. God damn, son, you're good.
So yeah, so you can troubleshoot, you can isolate a problem, you can patch around it. You know what I'm saying? You can patch around these. You know, so you have to have, it's pertinent that you have to have a patch panel in between your devices, your equipment. You have to have that. Now let's go behind the racks and I'm gonna show you the actual flow real quick. I saw it on paper, now you get to see it. All right, so.
You know why you have to isolate? You know why you need to isolate? You need to isolate the patch panel. Right? So LeBron James, think about it.
So if you have an equipment failure,
You're not broadcasting.
then obviously you know like if RD1 or like a Henry box goes out, now you can tune into another decoder, patch that into your main feed. You know what I'm saying? You're just patching around the problem. That's all you're doing. Same thing if you need to go on the bypass. You can patch around whatever problem that you're having with whatever equipment and patch directly to your transmitter. It's good to have a patch panel because you can isolate things.
There's a troubleshooting.
You can figure stuff out. You know what I mean? So you have to have a patch in between.
Plus,
Now,
I was gonna say, plus on top of that, if you were trying to use that still, say something was wrong in between, then you'd have to create a new cable to take it from there and move it to somewhere, wherever else it needs to go. With the patch panel, you can
so you patch around it. That's all it is, instead of running cables, because we have patch panels.
You can isolate the problem and you got a temporary fix.
A temporary fix. Keep in mind that a patch is not a permanent solution. You still have to fix the problem regardless. You know what I'm saying? So that's just to get you back to where you was, but in a temporary state. Does that make sense?
It's like the Band-Aid.
It is a Band-Aid. So you don't want to have a patch cable in there all the time. You still have to fix the problem. You know what I'm saying? So signal flow, again, where does the signal start at? Where else? So so off the satellite, it comes into
Decoders.
Right, into the decoder boxes off the splitter, right? So that's how the splitters up here. So it's coming off the satellite into these splitters, right? And then that's how you get your AFN programming feed into the decoders. And then out of the decoders, it comes out SPDIF, and split up to
Henry
box.
all right, and Henry box to
Patch panel.
patch panel. But before it comes out of the Henry box, it has to convert what?
AES.
AES. Why do we need to convert AES?
Because it's the cleanest Axia. And that only reads it.
Exactly. So again, see, man, y'all good.
You're
man.
like a hype man over there. Hey man, this is good stuff.
No, it's good. I mean, because y'all need to know this stuff before I can get into all the other stuff. This is just basic Axia stuff right now. You have to understand this part before that you can get into anything else, right? So again, Henry box, split up Henry box, converts to AES. Out of the Henry box, two outputs off the back, XLR connections. They're going directly to this patch panel, right? Because again, we use patch panel for isolation and troubleshooting, right? And then out of the patch panel, we go into our nodes here for audio. That's audio that I'm talking about. Now, you have live wire. You have audio and you have live wire. Live wire, come back here real quick and I'll show you. That's this green cable here. That's how the information is going to get across the Axia network, just through live wire. So once you have your audio in for your decoders, then it needs to travel across live wire so that every device within that live wire network is able to see it, to see all the audio that's being inputted into the devices. So you have audio and you have live wire. All good? Now, keep in mind that our system is different from everybody else's. We have the switch here. Our live wire connectivity is everything that you see on the switch. So instead of you guys having, you guys have live wire into your power stations. So your power stations is the switch, right? But instead of us going into the power station directly, we're going directly into the Cisco switch. Because again, like Mr. McCarron talked about yesterday, if you have a power station that fails, like for Studio Wave power station fails, all your devices on your A side of your nodes are gonna die. You're not gonna have no audio, no live wire connectivity. So every audio that you have going into it, you won't be able to see it in any other device that you want to look at other than this. Because again, the power station died. That's your primary means of live wire audio for this side of the rack, all your A side stuff. So you won't see anything. So if a power station dies with this in place, we're still able to see our audio. You just won't see audio from the power station, like your microphones. You won't get nothing from coming out of your speakers. So pretty much that studio's dead. You have to go into the working studio. All that stuff is still gonna work regardless. So you're just gonna have to fix the problem at hand, fix that studio, and hopefully it comes up. You know what I mean? Because again, that's a single point of failure potentially. This could be a single point of failure.
Sorry, now some question.
Oh, go ahead.
All right, so say that happens, say we lose the power station, we
Sure.
only have half our X nodes
Right.
that working right. How does that degrade our signal?
All right, so good question. Now, this node in particular, this bottom node, this mixed node, so we call this node 5. I'm calling this node 5. That node right there has your output that goes to your transmitter. So if that dies, what you're going to have to do is you're pretty much going to have to patch around that. So what I would do is since you guys, I don't know if you guys have these breakout panels at your station. Do you guys have these breakouts? I know you don't. I know you don't have it, but take a look at the back. Take a look at the back of this. What you're going to have to do is you're going to have to patch around. I'm trying to think. How would you do that? So it comes out.
My question is right.
No, go ahead.
All right, so you're saying that you lose basically your right side of the signals. You
Right.
lose the right hand side of the X nodes.
Right.
Will you still be able to transmit with the left side?
You can, but you're going to have to.
Do you need both left and right?
No, you don't need both. Your signal won't degrade as much. Now it depends because, and I'm going to talk about this. If your power station A was your master power station, if it's not set up to where if that dies, it's going to choose another master, then you're going to have problems. I'm going to be straight up with you. You're going to have problems. You know what I'm saying?
Now, I do have this question.
What's up?
All right, so with us in Bahrain, we've only got one studio.
You only got one studio.
Right now, the way our waller is set up, we route vMix 2 to primary transmission.
Right.
What is vMix 1? Is that for a second?
vMix
studio?
1 vMix 1 is your talkback function between studios.
Okay.
So but since you don't have a second studio, so this doesn't apply to you.
Okay. Now,
Even though it's set up in your station, if you was to have the second studio, then that vMix 1 will obviously be in play for you.
Okay, and so that's the reason why I was asking that.
Yeah.
So this vMix 2, does that go for both Studio A and Studio B? Or is there a
vMix
different setting for Studio A?
No, vMix 2 is only in Studio A.
Okay, so
Because remember, vMix 2, I'm gonna talk about this too, about the vMixes in the studio, but I'll tell you right now though. vMix 2, what vMix 2 is, that's your middleman between your PDM, your profanity delay, and your X node. Reason why we have to have the vMix in play is because your PDM, it puts out audio that the Axia X nodes it doesn't understand the PDM audio translation. So what the vMix does is it kind of you know, it's like a remedy for that, you know. So you send the PDM to the vMix, and then you send your vMix to your X node. You know what I'm saying? So your vMix is your middleman because the PDM and the X node can't talk directly. So so you know, you stick your virtual mix in between so that you can translate the audio better.
All right,
now,
well, the point I was trying to make though is there a destination on the XY switcher
Yes.
that you could switch if you were to lose power to the power station for Studio A, switch it on the XY switcher to switch over to Studio B for primary transmission?
now on the XY router, the way that it's set up is that your primary transmitter, it shows, right? It shows like number 5, primary TX or whatever.
Yeah.
That primary TX destination lies on that mix node. So if A was to die, that mix node is going to die. So that primary TX is going to fail. You know what I'm saying?
Okay.
That's going to fail. So,
I'm gonna go get this shovel,
yeah.
and I'm gonna be right back. You know
Okay.
what I'm saying? 'Cause we gonna just keep digging. You know what I'm saying?
Hey,
Can't be-
look, y'all got questions. I'm here to answer them because you know you guys are gonna ask this later, and then y'all gonna wonder why I didn't cover this, and then they're gonna be like, well, Ellison should have covered that. You know, that's why y'all here. This is a boot camp. Any questions that y'all have, I'm gonna answer them as truthfully as truthfully as possible. You know what I'm saying? So that's why we're here. Just keep digging, because obviously, you know, y'all have to know this too once you guys go patch.
So how do you
You
route
know?
it? Blue side A.
So, now that's a good question because I didn't even think about that. Now, if that node dies based off of that that power station dies, what's going to happen is, and this is what I would do, I would take this output, this cable, and I will move it to the side that's not affected, which is the B side. I would take that cable and physically move it over into a port because you guys are not using the B side outputs at all. Y'all not using them for nothing because you guys used to do AM. You guys don't do AM anymore. That was for the AM side. Now you have a free cable there for whatever. So what I would do is, since the output cable is connected to this breakout and this breakout goes to your transmitter, I will move that cable over to your B side. That way you isolate the A side. You know what I'm saying? So that's what you'll do. That's what I would do. I will move that cable over. You know what I'm saying? So right, exactly. Until you fix what's going on with not with this, but with the power station. Exactly.
Like a passion nigga. All right, that's good. All right.
Yeah. So I'll do that. Okay.
All right, I'm
All
sorry.
right. No, you good. I'm glad. You know, I welcome the questions because obviously they have to be addressed if something catastrophic happens, and that's a catastrophic failure right there.
That
So,
first group this morning didn't ask any good questions like this.
Hey,
But they didn't have IC.
Yeah.
that's
Yeah,
cool.
you're right. It's a lot of Air Force.
All right, so check this out. So y'all know the signal flow from the decoders to the nodes, right?
Right.
You know, now once we get down to our nodes here, you have, if you kind of squat down and look at like how it's wired in, we use the DB connectors for our input audio, right? Same thing with outputs too. We use the DB connectors. So there's 4 ports, right? Inputs, outputs. The full ports are this cable right here within this DB connector, with the multi-pin connector. So the 4 ports is on that. So now some stations wired using these Ethernet cables, which goes ports 1, 2, 3, and 4. But here, you know, we use our DB connectors. It doesn't matter which you use; they're going to work the same way. So just keep that in mind. So this is going to be your, your inputs for all your audios coming from the decoders. This input here up top. That's your top side. Your bottom side are your outputs. Your outputs are going to be something from, to your transmitter, to your breakout panels, to your transmitter, or actually, and to your Wohler channels, right? Nodes 1, 2, and 3, 4. There's 4 outputs on those that's going directly to this Wohler. Before it hits the Wohler, it goes to the patch, right? and then out of the patch it goes into your roller. So those are your outputs for your nodes. I got that?
Freaking ninja.
Yeah.
And like you said, the last one is that vMix, and that goes straight to the transmitter.
Right, the vMix is going on that transmitter. Now, whenever we log in, I'm gonna show you the vMix, like how it gets sent. How can you route sources to a destination? How you route audio to your nodes out. So let's go back around front. Any questions so far?